All right, we're about to dive into one of the biggest and honestly most personal puzzles in all of neuroscience, cognitive aging. Why? Because it's about the very essence of who we are as we get older.
You know what I'm talking about, right? We've all seen it. Maybe it's a grandparent who's still whip smart or a public figure in their 80s who is just incredibly sharp. It really makes you stop and wonder, what is their secret? How do they do it? Because here's the thing, it's an unavoidable truth. Our brains physically change as we age. It's just a fact of life. You know, just like we get wrinkles on our skin, our brain's gray matter and cortical thickness naturally decline over time. And those physical changes, they aren't just for show. They often lead to a real, measurable slowdown in our thinking. Scientists can see this super clearly when they test things that require mental flexibility, like, say, switching from one task to another. That tiny bit of extra time it takes you to shift gears, that's a real thing, a direct effect of aging. So that brings us right back to the core mystery. If all our brains are going through these same structural changes, why isn't the result the same for everybody? Why do some people manage to keep that cognitive edge despite all the normal wear and tear? Well, this is exactly what scientists are trying to figure out.
And the leading theory, the big idea that tries to explain this incredible resilience is something called cognitive reserve.
To put it simply, cognitive reserve is the brain's knack for finding flexible and efficient ways to get a job done, even when its underlying hardware is a bit compromised. And the key here, this is really important, is that it's not about having a structurally perfect brain, it's about having a functionally smarter one.
You know, a great analogy is to think of it like a mental shock absorber. Imagine two cars driving over the exact same bumpy road. The car with the better suspension is going to give you a much smoother ride. It's kind of the same with our brains. Two brains can have the same level of physical change, but the one with higher cognitive reserve can handle the bumps of aging way more effectively.
Okay, so a theory is great and all, but proving it? That's a whole different ballgame. How can we actually see this shock absorber in action? Well, a team of researchers at Columbia University designed a really ambitious 5-year study to find out. They recruited 52 older adults and then followed them for 5 whole years. So this wasn't just a one-and-done snapshot. Nope, they brought these folks back again and again for regular fMRI brain scans and a whole battery of cognitive tests tracking changes in both their brain structure and their performance over that long stretch of time.
Now, the main event was this mental agility challenge. First, participants would do a really simple single task, something like deciding if a letter on the screen was a vowel. Easy enough. But then they had to do a dual task, where they had to switch back and forth between 2 different rules. And the key thing they measured was the switch cost, that extra split second of reaction time it took to mentally change gears.
And this just perfectly illustrates the difference, doesn't it? The single task is like driving straight on an empty highway, pretty routine. The dual task, though, that's like navigating busy city streets with constant turns and quick decisions. That switch cost is a direct measurement of the brain's flexibility, how efficiently it can handle that increased demand. So the 5 years are up, all the data's collected. What did they find? Well, the results revealed something pretty remarkable about how the brain protects itself.
First, they confirmed what you'd probably expect. On average, as the participants' brains showed more physical, structural changes over those 5 years, their switch costs got higher. In other words, their mental gear shifting got slower. So yeah, that link between structural health and performance was definitely there.
But, and this is the huge question, was this a universal rule? Did every single person who had more brain changes automatically get slower?
It turns out the answer wasn't in the brain's structure, but in its activity. Using fMRI, they could actually see how much harder the brain worked when it switched from the easy task to the hard one. They came up with a score for this ramping up of activity, a measure of mental flexibility they called a DORT score. Basically, it's a number that shows how well a person's brain rises to a challenge.
And this is where it gets really fascinating. For the folks with the low DORT score, the ones whose brains didn't really ramp up much for the harder task, the connection was crystal clear. More physical brain changes directly meant a bigger slowdown in their performance.
But for the people with high DORT scores, the ones whose brains really fired up and got to work, everything changed. In that group, the link between physical decline and their performance slowdown practically disappeared. Their brain's agile response was literally acting like a shield.
And this leads us to the most stunning finding of the whole study. For the top 25% of participants, the group with the highest brain flexibility, that link between physical decline and cognitive slowing was completely gone.
Just let that sink in for a second. For a quarter of these older adults, the physical wear and tear on their brain had no measurable impact on their performance. Their brain's ability to adapt was completely making up for it.
And this wasn't just a fluke. The researchers themselves concluded that this flexible brain activation is, and I'm quoting here, a neural implementation of cognitive reserve. For the first time, they could actually see the brain's shock absorber at work, right there in the data.
So, what does this all mean for us? Well, this is a truly groundbreaking shift in how we think about the aging brain. It moves the conversation away from just inevitable decline and shines a spotlight on active, powerful resilience.
So what's the big takeaway from all this? First, cognitive reserve isn't just a cool idea anymore. Scientists can now see and measure a brain pattern that actually brings it to life. Second, our brains are not just passive victims of aging. They can actively fight back and compensate for physical damage. And finally, it suggests that the functional health of our brain, how it works and adapts, might be just as important, maybe even more so, than its physical structure as we get older.
And that leaves us with a really powerful final thought. What if the secret to keeping our minds sharp long into life isn't just about trying to stop the inevitable damage of aging, but is instead about building up our brain's power to be flexible, responsive, and resilient in the face of those changes? It's a whole new way to think about a long and healthy cognitive life.